Assalamu alaikum, dear students. Mrs. Iram Shahid is here for your grade 9 chemistry lesson. So today we will discuss some more examples of covalent bond, their drawing of their structures and explanation as well. Dear students, we are doing our chapter number 4, structure of molecule. We have seen ionic bond formation. We have completed many examples of ionic bond. Then we have started our discussion on covalent bond, their structure drawing and their descriptions. We have completed covalent bond structure, dot and cross structure for single covalent bond for more than 2 atoms. Now in this video lesson we will have to draw multiple bonds, dot and cross structures having more than 3 atoms, more than 2 atoms maybe. In this regard, in our previous video lesson we have finished example of carbon dioxide having double bond. Now we will see triple bond example over here to draw dot and cross structure between among the molecules having more than 2 atoms, and the example is for triple bond. Let's see. We have to draw a electron cross and dot structure, electron dot and cross structure for the following molecule, and that is HCN, used as insecticide. Insecticides is a chemical that is used to kill insects, so it's a chemical that is used for killing insects. So HCN, its name is hydrogen cyanide. Its structure we will draw, and it is example of a multiple covalent bond example for drawing, and having triple bond. So let's move with our next example, that is HCN. So hydrogen cyanide is its name, so it is used as an insecticide. Already we have seen its information statement, that you have also have to learn it for your knowledge, for your objective. Now you will see what we have to do. First we are going to write electronic configuration of all the atom present in the formula. So now there are 3 atoms, hydrogen, carbon and nitrogen. So one by one we will be writing their electronic configuration. Hydrogen have 1 electron in the valence shell, so we have drawn hydrogen electronic configuration. Then comes carbon. Carbon have got atomic number 6, and it will be having 6 electrons in the electronic configuration. We can see picture. First shell can have 2 electrons and second shell can have 4 electrons, as already we have discussed the subshell electronic configuration as well. 2 and 2 makes 4, so second shell L have got 4 electrons. And then comes nitrogen. Nitrogen atomic number is 7, and it will be having electrons in the first shell 2 and in the second shell 5. So still P or subshell is not complete, it is incomplete. So you can see that their outermost shells, they are incomplete, so that's why these elements, they reacted together to make a compound HCN, and they develop a covalent bond by sharing of electron, that we have to see. Now our second step is to find out the valence shell. For valence shell, when we will came to know, then we can figure out how many number of bonds they will be making. So valence shell of hydrogen have got 1, so it needs to complete 1 electron. Carbon have got 4, and nitrogen have got 5 valence shell in the their region. So hydrogen needs how many electrons to complete? Hydrogen needs 1 bond to be formed, because it needs 1 electron to complete its triplet, so it will make 1 covalent bond in this structure. So carbon needs 4, carbon have 4 valence shell electrons, so it will be having it's going to make 4 covalent bond. So 4 covalent bond by carbon and 3 covalent bond by nitrogen. So maximum number of covalent bonds are made by carbon, so carbon is a central atom, so that's why how we located central atom. We have seen that in HCN there are 3 atoms: hydrogen, carbon and nitrogen. So we have to arrange other atoms around the central atom. So 3 atoms are carbon, nitrogen and hydrogen. So you can see the size: carbon, nitrogen, almost they are using second shell, and hydrogen is using first shell, so you have to draw its size little smaller as compared to the second shell. So we have to go to their structure. So carbon is a central metal atom, as it will make maximum number of bonds, so it is drawn in the center. Now you can see the electron pair carbon is going to share with nitrogen is 3 electron pair, because nitrogen needs 3 electron to complete its valence shell, because nitrogen have got 5 electrons in its valence shell. So there will be 3 electron pair that carbon is going to make a triple covalent bond with nitrogen. And then there is hydrogen. Hydrogen needs only 1 electron to complete its duplet, so carbon is going to share 1 electron. Hydrogen cannot have more than 1 electron pair in its sharing region, rather in its duplet, because it do not have any capacity to accommodate more than 1 pair, because it is first shell. First shell can have maximum 2 electrons, not more than that. So now we will see HCN. Here you can see it's a lone pair. So this lone pair we are going to assign, that is left, which is left pair of electron, which is not being used in the bond formation. So electron pair which are in the sharing region, they are used in the bond formation. 3 electron pair here, so triple bond, and 1 electron pair here, so single bond. So lone pair, you have seen that nitrogen. Now we will see either duplet or octet rule is satisfied. Yes, it is satisfied for hydrogen. Hydrogen has completed its duplet, carbon has completed its octet having 8 electrons, and nitrogen also have completed its octet, and nitrogen is happy, carbon is happy, and hydrogen is also happy. So here is a structure final, that carbon has made 1 single bond with hydrogen, 1 electron pair. If there are 3 electron pair in the sharing region, 3 bonds. 3 bonds mean triple bond, and 1 lone pair is here. So carbon has made 3 triple bond with nitrogen and single bond with hydrogen. Yes, it's time to write description or explanation of a structure of HCN covalent bond, and stepwise that we are very in proper pattern we have drawn our covalent bond of HCN. Now that proper pattern, that rules followed that we used to draw the structure, same rule we will follow to write their explanation. So our first point was, yes, it was carbon has 4 electrons in the valence shell. So first we write electronic configuration to just understand about the valence electron. Then from valence electrons we will count the number of bonds it will make. So it needs 4 electrons to complete octet to have neon electronic configuration, so it will make 4 covalent bond. Then comes nitrogen. So one by one we have to discuss each atom, its valence shell electron and its number of bonds it will make, and then the covalent bond situation or sharing situation. So these are our steps that we have to find out, and also we have to locate lone pair and central atom. So first we wrote electronic configuration for carbon and counted its number of electron pair and number of bonds to complete its octet. Then for nitrogen we have written its electronic configuration, valence shell electrons, and then we find out it will make 3 because it needs 3 electrons to complete its octet, so it will make 3 bonds, 3 covalent bonds. and have an octet like neon. After completion, after sharing, it will be like noble gas configuration, that is a criteria for stability of electronic configuration. Now we come to our hydrogen third atom, have one valence shell electron and need one electron to complete duplet, and duplet like helium gas. So dear students, our next step is, yes, carbon is central atom, arrange hydrogen and nitrogen atom around it. So we located the central atom and then we arrange other atoms around it. So carbon share one electron with hydrogen, because hydrogen can have only one electron sharing capacity to complete its duplet, and nitrogen has three electron to be accommodated in valence shell, so it will make 3 bonds with carbon. So we will see carbon share one electron with hydrogen to form a single covalent bond, and 3 electrons, so carbon will make 3 electrons, he will share 3 electrons with nitrogen to form a triple covalent bond. So in this way they will satisfy their octet rule, that is 8 electrons in the valence shell. So hydrogen duplet is completed by sharing one electron with carbon, and carbon and nitrogen have completed their octet by sharing 3 electron pairs among them, forming triple covalent bond. So here was the structure of hydrogen cyanide, HCN. Hopefully dear students, you understand all the example that we have, how we have drawn them, how we have written their explanation step. So you will follow them, you will watch these videos. These videos, they are very important for you because they are your lessons from your book for you. They are very important, so watch them again and again so as to understand all the steps, and you will be able to solve examples in self-assessment and exercise as well. Thank you very much.